use this however you like. I'm going to whisper for all of our relaxation purposes, and maybe this will be really satisfying and tingly to watch as well, just to see things work out so nicely. But one thing I wanted to mention was that these all, as you can see here, follow a pattern. So they all have something in common. They each have 3 terms. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 3 groups, right? And you'll notice they all have just an x squared. So there's no number in front of the x squared. And that's on purpose. So really it's a coefficient of 1, but 1 times anything is itself. So we don't write the 1, but the coefficient there's all 1. And then you'll see that we have an x squared and then a plus or a minus something x. Something x. And then plus or a minus some sort of a number. Constant, okay? So that is on purpose. I wanted to take this opportunity to take a baby step and practice factoring in the context of using the backwards of the FOIL method. Now, a lot of times when this is first explained, you'll just get the rule right away. You'll just say, okay, what do numbers multiply to be this, and what do numbers add to be this? And that's okay, but today I wanted to take the time to focus on why and where does that come from. So that's why I'm willing to do all the work, so that we can really just zoom out and focus on what's actually going on. And then if you like this style, definitely let me know down in the comments, so that in the future we can definitely do some problems where we have coefficients that are not just 1, 4, -3, 10, whatever you like. It just makes the problem slightly more complicated, but it's not too bad. It's the same fundamental idea. There's just more to keep track of. And then we can also do factoring where we have more terms, so not just 3, but they're just other sort of miscellaneous factoring methods, and we can definitely do that as well, okay? So I just wanted to take this opportunity because really just practicing and practicing and practicing is what will get us to really digest the information. So I wanted to just practice this particular pattern, okay? So relax, relax, relax. Let me just start off really quickly to explain sort of the FOIL method. If you're learning factoring, you probably already know the FOIL method, but for us here, because we know that we have an x squared, usually we have 4 terms. So something plus something times, something plus something. And so that'll be like an A plus B times a C plus D. Like that. So we have 2 terms multiplied by 2 terms. Okay? And so when you multiply this out, you don't just do AC plus BD, even though it totally looks like it should be just the first terms times the second terms, but you actually use the FOIL method, which pairs everything together. It makes sure that we get every pair, so that every pair of terms where one term is in this one and one term is in this one. So the first, outer, inner, last, FOIL. It's just a mnemonic that we can use, since that spells out a word. And first would be the first of each binomial. So each pair like this, the first of each would be A, C, and we multiply those together. And then outer would be of these 4. We're taking the outer 2, so that's AD, and we're going to add between all of these. And then the inner would be B and C together. So you have these 4 terms together. We have BC. So basically just be the second of each binomial, so b, d. So this is just like the letters so that they spell out a word. That's why it's FOIL. And sometimes you'll see it drawn out like first, multiplying the first, the outside, the inside, and then the last, like that. So anyways, you've probably already learned this before. If not, then don't worry about it, but I wanted you to know where this was actually coming from. So basically, we would expect, assuming that no terms combine, we expect actually 4 pairings, 4 terms when we multiply 2 by 2, when nothing combines. However, if we're taking like a quadratic like this, and we are trying to factor it like this, oftentimes the middle terms will combine to give me this middle term. So we do, so for instance, since we already have the x squared here, we know that the first we're going to choose a and c, so that a times c, the first terms, multiply to give me x squared. And the simplest way for that to happen is if one is x and the other is also x. So we have x plus something times x plus something. And with this pattern of something squared plus 3x plus 2, that is how we're going to break it down. We're going to break it down into linear parts. Okay, so that's our a and c. So that's why we're not doing like an x squared and 1. That's so not necessary. We want to break it into x times x. And you know, with your exponent rules, x times x is x squared. So for all of these, we are expecting something that looks like this. And we're just going to look for what is that something and what is the other something. So let's say I put this as a and b. That's what we're looking for. And notice that if a and b, or if a or b are negative, that's okay. That's going to just make us have a factor of, you know, x plus negative 2 is equal to x minus 2. The plus minus 2 makes it minus 2. And this is where math just keeps building on itself, but you can either think of this as having a secret 1 there and 1 times, so a positive times a negative is a negative 2, or you can think of it like on a number line being like, okay, x and then plus going to the right, and then so, but you're going to the right negative 2, which is kind of like just going left 2, so x minus 2. In either case, I'm writing it as x plus a and x plus b just to keep it generalized. And so when we multiply this out using the FOIL method, we basically do the first, which already multiplied x squared, the outer, which would be bx in this case, the inner, which would be ax, and the last would be AB, like that, see? So there's a particular situation, we're just doing our F.O.I.L, but notice that these two, the outer and the inner, combine because there's a like term of our x there, and we can actually factor out that x and say that is b plus a, because that's like our distributive property, right? So basically, we have an x squared plus b plus ax plus ab. So now we have our exact pattern. We see that we already have our x squared here, but our b plus a is the number in front of our x terms, and our ab multiplied together give us these numbers. So that's what we're looking for. When we factor, we're going backwards. We're figuring out what two numbers multiply to give us the constant and yet add together to give us that middle coefficient. And our x squared is taken care of because that's how we chose it for here. So that's what we're going to keep in mind here. I hope that that is making sense. I know that, you know, we could just it's not just 1, 2, 3, it's actually 4, but the two middles combine. Okay, so we'll keep this in mind when we try these problems. Another thing I should mention right before we start is these should all work. So for those of you who have already learned this stuff and are always trying to look for loopholes, this is not the situation where we're going to use the quadratic equation and then factor using x minus 1 root times x minus the other root. We're not finding the zeros, we're not using the quadratic equation, even though you could. But if you can recognize factoring with integers, so in this case I'm telling you ahead of time, these have integer parts. So our a and b are going to be integers, meaning, we're not expecting fractions, square roots, nothing weird like that. We're not going to do irrational stuff or anything. We are just going to factor this in the context of using our backwards FOIL method, okay? Plus, if you can get used to doing this pattern, it saves you so much time. You don't have to do this negative b plus or minus square root of b squared minus 4ac blah 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 blah. You just sound like you're overcomplicating it. You don't need to for this kind of stuff, okay? You can give yourself a headache with that stuff later. There's plenty of opportunities. Okay, so let's try to keep that in mind for now for this part. So once we get used to the pattern, these will go pretty quickly. So we have x squared plus 3x plus 2. So we know we're looking for x, and we're looking for plus something, minus something. And we want those two numbers to multiply to 2. So what two numbers, integers, multiply to 2? So, fun fact, 2 is prime, so it's just 1 and 2. And it could be -1 and -2, because remember, two negative numbers multiply to be positive. And so just basically, if they have the same sign, if two numbers have the same sign, so they're either both positive or both negative, when they multiply, they become positive. And if one is negative and the other is positive, then they multiply to be negative. So in this case, we have a plus 2, so they have to have the same sign. So one of these is basically A and the other is B, because we're looking for AB to equal 2. So which pair do we pick? Well, we also know that we're looking for B plus A or A plus B to equal 3 in this case. So does 1 plus 2 equal 3? Yes. So we're going to take this one, and a -1 minus 2, or a -1 plus -2, however you want to think about it, is -3, and that's not -3. So we're not going to pick this one. Okay. So just because we have an x and an x here, it does not matter if you write the +2 here and the +1 here, or a +1 here and a +2 here. We can just write whichever order we like. But notice that if we happen to have to also take care of the situation, if there's like a coefficient in front of the x squared, let's say 3x squared, and we have to deal with like a 3x and an x here, when we do the outer, then we would have, in this order, we would have 2 times that 3, which is 6, plus 1, which is 7. But if we switch the order, so 2 here and 1 there, we would have 1 times 3 plus 2, which is 5. So it does change our answer. So like I said, there's just a little bit more to keep track of if we have that coefficient. But in this case, we just care about the pair, and it doesn't matter which order. Plus, you know that multiplication is commutative, meaning the order doesn't change our result. So just pick one. Once you find the pair, you are good to go. And the great thing about these is as long as you have an answer, you can try to FOIL it back out to check it. So x times x is x squared. That's your first. Your outer is 2 times x. Your inner is 1 times times x, which is plus x, and your last is 1 times 2, which is 2. And then these two combine to be 3x. 2x plus x is 3x. So x squared plus 3x plus 2, which is our original problem. Ta-da! So good, right? So nice. Okay, so same reasoning for the rest. X squared minus 2x plus 1. So what two numbers multiply to give me plus 1? Well, 1 and 1, or negative 1 and negative 1. Because I still have my coefficient of just 1, so x and x. Which pair do I pick? Well, I want them to add to be negative 2. And 1 plus 1 is 2, not negative 2. But negative 1 plus negative 1, which is just negative 1 minus 1, is negative 2. So this pair. So then we just put x minus 1, x minus 1. So basically A is negative 1 and B is negative 1. But like we said, with our plus case, x plus negative 1 is just negative 1. So if you're used to just kind of tacking on that negative with it, you can just go ahead and do this right away. So notice that these two are actually the same factor, which is fine. This is a perfect square, so you can write it as that if you wish. And if you were to check that, there's a special sort of the x squared, minus or plus 2ab plus b squared kind of formula, but you can also just FOIL this out to check. So x squared, and then the x times negative 1 is negative x. The negative 1 times the x is another minus x. The negative 1 times negative 1 is plus 1. And these two combine to give me negative 2x. So you see, when I'm writing out just these lists, it's really just the coefficient of the x part. So this is a negative 1. Sorry, I got a little bit cut off there. I'm not sure where it got cut off, but when I'm basically multiplying the x minus 1 times x minus 1 out, when I FOIL that out, notice that I am really, when I write out these pairs, I'm looking at the coefficients of the x parts when I FOIL that back out. So negative 1 minus 1, and I want those to add up together, in this case negative 2, to equal the coefficient that I had. And we're only looking at pairs that already multiply to equal this last part in the first place, because that's all that we need to consider, is that the last parts still multiply to this. Okay, cool, nice. So now we're just moving right along. We have number 3, x squared minus 6x plus 8. So I know it's going to have x and x. I want two numbers that multiply to 8. So either 1 and 8 or 2 and 4. And then also the negative versions of that. Negative 2, negative 4. And like we said, since the coefficients are 1 here, x and x, we don't have to worry about the different orders. So 1 and 8 and 1 would be the same situation for this kind. So which pairs add to give me negative 6? 1 plus 8 is 9, so nope. 2 plus 4 is positive 6, so nope. Negative 1 minus 8, nope, is negative 9. Negative 2 minus 4 is negative 6. So x minus 2, x minus 4. Very, very good. So I picked these pairs in the first place so that they already multiply to 8. And those are the only ones I need to check. Then I check which ones add to actually equal this middle part. Nice, very good. So number 4, we have x squared plus 4x minus 12. So in this case, again, we know it's x something and x something. Since since we have a minus 12, we want numbers that multiply to be negative 12. So if it's negative, it means one is going to be plus and the other is going to be minus. And here's a little trick here for you. You can pick whichever order, so as long as we're consistent, it's okay. But one has to be a plus and one has to be a minus. So factors of 12, you could have 1 and 12. And so we're looking for like a minus 12, right? Or negative 1 and 12. So that when they multiply, if one is positive and the other is negative, when they multiply, it's negative. We have 2 and 6. So 2 and negative 6, negative 6 and 2. 3 and 4. And I think that's it, right? That should be every pair. Sorry, I messed up there. It's actually negative 2 and positive 6, or negative 6 and 2, right? So, and that actually happens to be the one that we need, because 1 minus 12 is negative 11, so not that. Negative 1 plus 12 is positive 11, so not that. Negative 2 plus 6 is indeed 4. So that's the one we're going to use. This is the pair. Negative 6 plus 2 is actually negative 4. So not that, because we have a plus 4 here. 3 minus 4 is negative 1, so nope. And negative 3 plus 4 is 1, so nope. And this reasoning will get faster as you practice, but we know that this is the pair, negative 2 and positive 6, which means I'll just write the negative 2 here and the positive 6 there. So the signs kind of give away if we're going to have a plus or a minus. If you have a plus here, like this number, that means they're either going to both be negative or both positive. And then you can tell if it's positive or negative based on the sign of the thing on the inside here. If it's negative, then you know that one's going to be positive and one's going to be negative, and you want them to add up to equal whatever this term is. Okay, very nice. So x plus 6 times x minus 2. Again, you can FOIL this out, and as you practice this FOIL, you can just do this in your head. You have your minus 2x plus 6x, that's a plus 4x. 6 times negative 2 is negative 12. Nice. Okay, so number 5. So x squared plus 12x plus 20. So again, x and x. Since you know everything is positive here, that's kind of nice. You just put your two pluses in, because if you had a minus and a minus, then when you add those, it should be a minus, but you don't have to worry about it here. So now we're just looking for two numbers that multiply to be 20 and add to be 12. So factors of 20 would be 1 and 20, 2 and 10, 4 and 5, and I think that's it, right? So 1 plus 20 is 21, 2 plus 10 is our 12, so that's exactly the one that we want. And of course, as you practice factoring it, you can do that in your head and you won't have to write out every single pair, just from doing so much practice like this. Very good. So then 6x squared minus 13x plus 36. So x. So I see a plus here, which means that our two factors are either going to be both positive or both negative, so that they multiply to be positive. But we also want them to add to be a negative number here, so we know that they are both negative. So what numbers? Basically, if we put the minus here, we can just think of which numbers add to be 13, but let's focus on the factors so that we're consistent. So it's either going to be like negative 1 and negative 36, or negative 2, plus minus 36 is the same as negative 1 minus 36, which is negative 37, so nope. This is negative 20, so nope. Negative 15, so nope. I like this, negative 13, so that's good. And then that's negative 12, so nope. So just this. So minus 4 and minus 9. Very good. Nice job. Okay, and then number 7, 8, 9, and 10, I'm just going to write out and not speak, just in case you're getting drowsy and falling asleep. I'm just going to go ahead and do them. I'll just write out the answers. So you'll end up doing it really quickly, knowing there's a negative, you know one's negative, one's positive. You just think of what outer number minus this inner number gives me negative 1. You'll be able to do that pretty quickly with practice. So x squared plus 18x plus 81. This 81. This 81 can be 9 and 9, but it can also be 3 and 27. But this works, so 9 and 9. So 40 and negative 10. So that last one got cut off there, and might as well because I was falling asleep and I kind of messed up anyway, because I wrote 8 and not 18, but it's x plus 3 and x plus 6, because the factors of 18 are 1 and 18, 2 and 9, and 3 and 6. And again, because we have just an x squared there, we don't care about the order, because we could just flip these two. And so we just want to have those add up to equal 9. So 3 and 6 is the pair that we want. So x plus 3 and x plus 6. And this is why it's always so helpful to make sure that you check mentally whenever you do factor. Just check really quickly that your FOIL works back out. So my x squared is good, my outer is 6x, inner is 3x. Those add up to be 9x. My last is 3 times 6, which is 18. Perfect. Very awesome job.